Today, I'm going to be covering the SANS 1534 2018 edition 2 version of the resin capsule for the use of tendon-based support systems. Some background to the standard. The standard that was published in 2004, edition 1.4, was in use up until 2018. However, there was work done in 2010, which was not completed and therefore not published. And in 2011, there was another attempt to publicize the new edition, and the work was not completed either there. Then in 2018, this is the version that is now available, and it is published some background on the 2018 edition 2. The work on this standard renewal commenced back in 2016, and the 10 members that participated in the updating of the standard were the following members: Mr. Donald O'Connor from Manova RSA, Billy Mathebula from the SABS, Werner Bellingham from Rockbolt Technologies, myself, Alf Piroddi, RSC Kusasa Mining, and Mr. Dave Neal representing the customer. Notes that I want to highlight here to the purchasers. The following requirements shall be specified in a tender invitation and in each order or contract. The type, which refers to the set time, which could be a 30 seconds set time resin capsule, 60-second set time resin capsule, etc. The shear strength of the products, namely a S19 or 23, S23, the S19 referring to a 19 MPa shear strength, and the S23 to a 23 MPa shear strength. The capsule dimensions. Note, the requirements in A, B, and C may be specified by reference to a manufacturing data sheet where available. And the other important note that I want to just bring to the attention is note 2. The purchaser should note that the performance of the rock bolting system employing resin capsules is influenced also by external factors. Purchasers should establish the suitability of the resin capsule for their particular condition and purpose. Inspection and tests. The comparison between the old standard and the new standard that is currently applicable. On the capsule dimensions, there was no change. On the test for freedom of leakage, there was no change. On the rigidity test, there was also no change. On the test for the shear strength, there was no change from the old standard to the new standard, and the same applied for the set time testing. However, on the test for the flash point, this was debated, and then it was decided to remove it as the flash point of the resin capsules are high and it was not applicable to the standard. The pull test remained, however, there was a change in methodology. The viscosity test remained the same, and the resin mastic content of the capsule was also removed. I will discuss this and give the reason why it was removed. On the pull test, the old version, the 2004 version versus the 2018 version, the pull test in the SANS 1534 2004 version was done by drilling a hole into a concrete block with a 20 millimeter diameter hole. The length of the hole was 350 millimeters. The bolt used for the test was a 16 millimeter rebar bolt, which the resin capsule was a 19 millimeter diameter capsule with a length of 300 millimeters. The displacement allowed during the test was not more than 11 millimeters at a continuous load of 100 kilonewton for 5 minutes. The pull test methodology and application in the 2018 version is as follows. It is done in a steel pipe with an internal diameter of 26.5 millimeter using a 20 millimeter diameter bolt. The bond length is 250 millimeter. The capsule diameter for this test that is used is from 19 millimeter diameter to 26 millimeter diameter. The load applied is 100 kilonewton with a maximum displacement allowable of 2 millimeters. Thus, the annulus in this test is 3.25 millimeters. There is also a second test done for the larger hole, mostly used in the hard rock mines. This is also done in a steel pipe with an internal diameter of 36 millimeters using a 25 millimeter diameter bolt. The bond length, remains at 250 millimeter. The capsule diameter for this is a 27 millimeter to 35 millimeter. The load applied here is 120 kilonewton with a maximum displacement allowed of 3 millimeter. Thus, the annulus radius in this test is 5.5 millimeter. It must be mentioned that the steel pipe is not a smooth pipe. The pipe has a thread cut into it to resemble the rock, which has been rifled due to the drilling process, which allows you the friction points of the rock in the hole, and it was replicated by applying an internal thread into the steel pipe. Other changes from the 2004 to 2018 standard. The set time in the old standard 2004 standard did not include the newly 20-second or the 2-speedy capsules, which is now available in the market. And the resin mastic content, which I refer to, I would get back to, was based on the ratio of the resin to catalyst content of the capsule. This content of the ratio, the amount of resin to catalyst in the resin capsule, has no influence on the performance of the resin capsule and has thus been removed. The ratio that was applied in the previous standard was more for controlling the manufacturing process of the two different percentage components of each, but due to technology and the performance of the resin, which has been greatly improved, this is not applicable to the standard anymore. It is important to note that the 2018 version, the pull test, or as we term it in our industry as a short encapsulation pull test, SAPT, refers to a test conducted in a controlled environment, which refers basically to a laboratory where these tests are conducted and the specimens are prepared. In the underground short encapsulation pull test, normally falls outside the parameters of the 2018 standard, namely the 20 millimeter bolt in a 26.5 millimeter hole diameter, or the 25 millimeter bolt in a 36 millimeter diameter hole. With the tests and performances of products today, we know that we apply a 20 millimeter bolt into a 34 diameter hole, and there are other variations which are applied. It is important, though, for the rock engineer to determine her own specifications for the underground short encapsulation tests, because, as I've mentioned, there are variations to these parameters that are applied. Important for me to note here is that the diameter and the length of a resin capsule is important, because these measurements are used to calculate the resin requirements for a full column grouted hole and the bond length of a point anchor, or the bond length that the rock engineer would like to apply to his installation. The SANS 1534 2018 edition 2 standard for capsule dimensions reads as follows. The dimensions of a capsule, when measured in accordance with 6.2, shall not vary in length by more than -5 mm to +10 mm and in diameter by -1 mm to +0.5 mm from the nominal dimension given on the box or label. For capsules 1000 mm and longer, the length shall not vary by more than -10 mm to +10 mm as specified in Annexure B. The instruments used for the above measurements is a verified steel rule used to measure the length, and this is done from measuring the capsule length from the inside clip on the one side of the capsule to the inside clip of the capsule on the other side of the capsule in millimeters. The diameter is done or measured using a verified go-no-go gauge. A vernier used in this application is not suitable as the capsule is not completely 100% circular and round in diameter, and if the vernier is moved around the capsule, various different measurements will be measured, and thus the vernier is not considered as a tool to measure the diameter of a capsule. The reason I mentioned these variations that can be applied in the measurements of the capsules and the variations that can occur and still allowing the capsule to fall within the standard due to the variations that can occur is basically when we're using the following formula to calculate the embedded length required for the capsules. Calculating the length of the capsules is required to obtain your embedded length. The equation basically reads the capsule length will equal to the hole diameter squared millimeters minus the bolt diameter squared millimeters divided by the resin diameter squared millimeters times the bond length. So as we stated that we want to consider, I'm just putting it out there that you could possibly consider adding a percentage factor to your calculation for an installation using multiple capsules, especially when the length of the capsules are 1000 millimeters or longer, a -10 millimeter in the length of the capsule, the physical capsule itself, and the -1 millimeter in diameter, which can occur and still apply the capsule to be within standards, will comply, but this may not provide you with your calculated embedded length, and it will not be accurate. Therefore, in the example that I'm using, is if the capsule is in actual fact -10 millimeter on a 1000 millimeter capsule, that equates to 1%. And if the diameter of the capsule is actually 1 millimeter smaller than the nominal diameter, that equates to 3%. I've used a factor which I normally term a waste factor, added to my calculator in determining the capsule lengths. That has done me well in the past and in the present in calculating accurately, because there are also other factors that we need to consider in the calculation. That could be the possible over drilling and reaming that occurs during the drilling process of the hole, and this will add to the reduction of the actual embedded length if these capsules have these variations in them. So yeah, it's something for you there to consider when you're actually doing your calculation. And yeah, like I've mentioned, the calculations that I've done, you can normally see when you have completed an installation, that you do have your embedded length of your requirements that you have calculated. Thank you, and thank you for your time and listening. If there are any questions, you can ask them now. Thanks.